Well, good morning, guys and dolls. How are you? Hope you guys had a great long weekend. Hope you got all caught up. We're kind of finishing up circles. Yes and no. But I wanted to kind of give you the formulas for all the circles in one spot because the problems do tend to be kind of crazy by the time we put them all together. So we're going to do a real quick review. As you can see, everything plus examples are here on these sheets, so it's going to look a little long, but we've learned all of this except for one new rule that we're going to end up doing at the end here today. Alright, so we started this way back when with the central angle, when we ended up with a circle with the central angle and that the angle and the arc were congruent. Okay, and then we ended up with some theorems. In a circle or congruent circles, congruent central angles have the congruent arcs. So if these angles are congruent, then the arcs are congruent. That kind of makes sense. Same measure, same angle, same arc. Okay, then we went to the inscribed angle, where we're not at the center anymore. We moved away from the center, and then we realized that the arc was bigger than the angle. How much bigger? Twice as big. So if we had the arc, we could get to the angle very easily by taking half of it or dividing by 2. 82 divided by 2 gives me the measure of x. And we said, hey, this is pretty easy. This is just 41 degrees. Then we could remember that we had a very important line called the diameter. That the diameter cut this circle in half. This is going to be big because you're going to use this later on again today. If you see the diameter, it's going through the center. We know that that's cutting this off at 180 degrees. And then again, if the angle is on the circle, if this is 180, it's half. That would be 90 degrees. And then we got into these quadrilaterals inside of the circle, and we knew that the opposite angles were supplementary. All right, x and y equaled 180, and a and c added up to equal 180. They were supplementary. And then we got a little bit more confusing because the angles and the legs of the angle started to overlap. But we said, hey, if this angle and this angle are congruent and they're biting off the circle or cutting off the circle in the same arc, well, angles that intercept the same arc or the same arc that intercept two angles, that those two angles are congruent. So this is all kind of a review. But when they start to get crazy looking like this, we really have to take out our highlighters and highlight. We're talking about this angle here, which is the same as this angle here, and then that this is the same arc for those two angles. Okay, nothing new yet. And then we went into tangent chords. What was a tangent? A tangent was a line that touched the circle at exactly one spot. And there was a special rule that if the tangent intercepted the radius, then it was perpendicular. Okay, but don't confuse the rule with the tangent and the radius to mean all angles are 90 degrees, because they're not. This one you can see is not touching the radius. How do we know it's not the radius? Because it's not going through the center. So we had a special case here. We had a special case that if you had a circle and you had the radius, and that radius happened to be touching a tangent line to the circle, then it formed 90 degrees. But if and only if this was the radius, or could it have been the diameter? Sure, because the diameter is nothing but 2 times the radius. and it touched this tangent line, then it was 90 degrees. Okay, but this tangent to this chord is still nothing more than an inscribed angle. And we know that the arc was twice as big as the angle. So we simply take the 148, cut it in half, and we know that this would be 74 degrees. Because it is nothing but an inscribed angle. This is the special case. Okay, so I'm just trying to go through, and I wanted to make sure that we were reviewing a little bit. Okay, then we ended up with these angles that were not in the center, not on the circle, but somewhere in between. And we then said that if this angle and this angle are vertical angles, then we could find an angle or the arcs by using the formula 1/2 the sum of the intercepted arcs. Or I like to write it arc 1 plus arc 2 and divided by 2. Something that I wanted to bring your attention to is when we're adding these, it gives us this angle, the angle in between. They're not always going to give you this angle. More than likely, they're going to give you this angle on the outside. But that is nothing but a linear pair. This angle, O, I'm going to call it O and E, even though it's the center of the circle, O and E are congruent. But we do know that these are a linear pair. So we could find E, angle E, by taking 180 minusing this X. This idea of a linear pair is going to be really, really important as we go along. So don't forget things like linear pairs. Okay. So again, we've just kind of summarized everything that we had. These two are add the angles, cut them in half, and you add the arcs, cut it in half and you find the angle. The arc plus the arc, take half of it, gives you the angle. Don't forget to write this part of the formula, because a lot of times they're going to give you the angle and they want you to solve for the arc. So I'm going to take this example and we're going to say, hey, let's pretend, since we already know that this angle measure is 43, they're going to give you a problem that looks more like this. Where they're going to give you this is 32. This angle we know is 43. So let's find and give us this one. So 180 minus 43. Okay, so 180 minus 43 is 137. So let's pretend that they give me this. Okay, so they give me this arc, they give me this angle, but they're looking for this arc over here. Okay, so putting this whole linear pair idea into place, if we know that this angle is 137, well, it forms a linear pair with this segment, so we can find this measure right here. Okay, so 180 minus 137, we find out that this angle here is 43 degrees. So this angle, I'm going to write 43 degrees, is here. If this angle is 43 degrees, we know that this angle is 43 degrees. Okay, so in this case, they're giving me the angle and they're giving me this arc. They're looking for the second arc. So the angle equals to 1/2 arc 1 plus arc 2. We know that this arc is 32. We're going to pretend that we're looking for this arc. And this time they give me the linear pair to this. We found 43. And then we simply say that 43 degrees equals